In the previous video, we explored what is linked list and types of linked list. In this video, we will continue our journey by exploring the common operations in linked list, insertion, and how to implement insertion. So, without any further ado, let's get into it. In this video, we will be inserting to a singly linked list. So, when I say linked list, I mean singly linked list. So, the insertion operation can be performed on a linked list in three different ways. That is, inserting at the beginning of the list, inserting at a specific location in the list, and inserting at the end of the list. Now, let's look at each different ways in depth. Let's begin with insertion at the beginning of the list. If you think about it, inserting at the beginning of the list is easy, as we already know that our head pointer points to our first node of our list and all the other nodes points to their next node except the tail node, which points to null. We have to make our inserting node point to our first node in our linked list. Then we have to make our head pointer point to our inserting node. That's it. We will be inserting our new node. So the approach is to make the first node of linked list linked to the new node. Then remove the head from pointing to the original first node of linked list. And finally make the new node as the head of the linked list. By following this approach, let's implement insertion at the beginning in terms of code. We first create a function insertion at front, which takes two parameters, the head pointer and the data to be inserted. Then we create a new node and allocate memory to it. Then we set the data of the new node to our data, which is to be stored. We then set our new data's next pointer to be our linked list's current first node. And finally, we set the head pointer to point to our new node. That's it. This will insert our new node at the beginning of our linked list. Now, how can we insert an element at a specific location in the list? If you have understood the previous insertion, then you might have some rough idea. It is simple. We will get the previous node of the linked list where our new node has to be inserted as a parameter. We just have to change the data of our new node, its next pointer to the previous node's pointer, and finally make the previous node's pointer to our new node. That's it. It is similar to insertion at the beginning. So the approach is to first check whether the previous node exists or not. If it does not exist, we terminate the process. If it exists, create a new node and initialize it with the data to be inserted. Change the next pointer of new node to be the next pointer of previous node. Finally, change the next pointer of previous node to be the new node. By following this approach, try to implement it by yourself. Then you can check to verify. We create a function insertAfter, which takes two parameters, the previous node where our new node has to be inserted and the data. According to our approach, we first have to check whether the previous node exists or not. So we check whether our previous node is null. If yes, we print a warning message and terminate. If not, we create a new node, assign it the memory, put in the data, set its pointer to point to the next pointer of the previous node, and finally make the next pointer point to our new node. That's it. Our final type of insertion is to inserting at the end of the list. Here we just have to go to our last node and change our last node to point to our new node instead of pointing to null, and our new node has to point to null. That's it. So our approach is to go to the last node of our linked list, change the next pointer of our last node from null to new node, finally make the next pointer of our new node null to indicate the end of the list. That's it. Now let's look at its implementation, and if you try, it is good for you. We create a function insertToTail, which takes two parameters, the head pointer, which represents the beginning of our list, and the data. We create a new node and assign the memory. Then we create another node called last, which would contain our last node of our list. But currently we do not know our last node. We only know our head node, so we assign it. Then we put our data to our new node and point our next pointer of new node to null. Now we check whether our linked list is empty by checking whether our head pointer is null. If yes, we point our head pointer to our new node and terminate. If not, we run a while loop which checks whether our next pointer of our last node is null. And in the while loop, we assign our last node to be its next node. Basically, the while loop traverses over the entire linked list until it finds our last node in the linked list. When it finds it, it assigns the last node or it points to our last node. Now, with the last node in our hand, we can change its next pointer to point to our new node. And yes, we did it. We now know the different methods how we can insert to linked list. In the next video, we will talk about deletions. So make sure to subscribe, and if you found any value in this video, then consider hitting the like button. Finally, congratulations and signing out.